about fractions. We're going to review. The primary focus is to review fractions. And if you are looking at this stuff and if you are like, whoa, I don't remember any of this fraction stuff, then shoot myself or Tracy a message. Maybe hop into Tracy's session on Friday to get some more instruction. But remember, you do have...
What's it called?
What's what called?
The session.
The session on Fridays?
Yeah, where do I find it?
Okay, I gotta add.
Is it that essentials thing?
No, it's...
I never found out what that was.
Do you have essentials on your schedule?
Yeah. I don't know what that is.
Stay after class and I'll talk to you about it.
Okay. Is it a bad thing?
No.
No.
Okay.
Yeah, I'm like that too with meetings. I'm like
it has an assignment, but I did the math and it doesn't count towards the rest of the assignments.
Oh.
So
we'll get it figured out.
Yeah, that's something worth to talking to Tracy about, definitely. But
all right.
I will put the link for, I got to figure that out, on our course. But for right now, Tracy, you were just inviting people?
Yeah, so on last Friday, there was like maybe 5 or 6 kids that didn't have all their math done. So
Okay.
I just sent an invite through your emails.
Oh, great.
And nobody showed up and I was so lonely. I was like practicing math by myself. So
oh no. So yes, I'm gonna recommend go get your math done. It's the easiest way to get it off of your list.
We can add that link to your session or to your course page, right?
Yeah, I think that you have to add it. I don't know if I can just copy and paste it, but I got to get you added as a teacher to the course.
Okay. We'll get it figured out.
Unless you are. We can figure that out after today.
Okay.
Yeah, guys, I want to really encourage you, especially after this week. We're talking fractions and looking at scores of what I just graded. Yeah, Lauren, that's great. But looking at scores of what I just graded, some of us, need to review and look at fractions. And remember, if you go through iExcel or Math Excel, and if you get a low score, you can redo that assignment as many times as you need to. So there's no need to have a low score, right? That's the no fractions mood. Okay, so here's my first math question of the day, just to get our brains thinking math. What do you guys think? Are there more inches in a mile or seconds in a day? What do you guys think? No problem. Cole says seconds in a day. Who agrees with Cole? Nolan also says that. Why do you guys say that?
Well, because 24 times 60 times 60 times 60 is a lot.
There you go. You don't even have to figure out what it is. You're so right. I like your reasoning there. There's a lot of jumps there. You have to go from seconds to minutes, minutes to hours, hours to days. There's a lot.
Guess what?
Oh, yeah?
I'm eating a fork with cereal.
Oh, hey. Nice.
How are you eating a fork using cereal as utensils?
That's talent right there. That totally is. But you guys are right with that reasoning. Good job.
Oh, you're eating cereal using a fork as utensils. I assumed you were eating the fork.
No.
No, I'm eating a fork.
It's a good time. Right? And this is right around lunchtime, so I totally get the snack need. I get it. Okay, so this is what you guys have due this week. You have a math mindset lesson. Then you have 3 Math Excel lessons. Okay? So there's stuff on equivalent fractions adding and subtracting fractions, and multiplying and dividing fractions. And we're going to talk about all of it today.
Aren't equivalent fractions the ones where the numbers are different, but if you simplify them, they're the same thing?
Kinda. But speaking of that, we're going to talk about that right now.
Oh,
How do you
cool.
like that? All right. So equivalent
Oh, I was
fractions.
right.
Yeah, you got the idea there, okay?
I'm just bad at wording things.
That's okay, no problem. Equivalent fractions are fractions that have the same value even though they look different, okay? So you might have like a 1/4, and you might have to get a different denominator to make the fraction match a different fraction. So we do that by multiplying the top and the bottom by the same number. You might have a higher number that you have to get to a lower number. To simplify, we do that by dividing. Just to refresh, what is that top number of a fraction called?
Numerator.
Numerator, good. What about the bottom?
Denominator.
Yes, very good. Denominator.
We are big smart.
Yeah. Heck yeah, you are. Very good. Very good. Okay. So, yeah, what you guys might have to do is a lot of simplifying or multiplying to get the same denominator so you can add them. So, note-taking wise, what do you guys think? Should we be writing this down? I'm going to say, yeah. I'm going to say if you don't remember what equivalent fractions are, then you should be writing them down. But if you remember what they are, then maybe just stick to examples and write that down. But you guys should have a notebook, and you should be working through problems with us, because it's just fun that way. It is. Okay, so when you have a fraction, most commonly you will need to write it in lowest terms. Okay? So what that means, first step, is you have to understand or list the factors of both numbers. And factors are what numbers you multiply to get that number. Okay, so for example, we have 15/30ths. And you guys might be able to look at that and tell me right away what number can you divide the top and the bottom by. Can you guys see it? 3 would work. Yup, 3 would work totally. If we divided by 3, got to do the same on the top and the bottom. You would get 5/10. You could also do 5. Yup, Cole is saying do 5. And then in this way, you get 3/6. But we're not quite done yet. 5/10 and 3/6 can go a little bit lower. There's another
1/3.
number. Not 1/3. What could you divide 3 and 6 by?
Yeah, but 1/2.
1/2. Yeah, you could. That's okay. You could also divide it by 3. Top one
Also,
here.
sorry
Divide by
if
5.
y'all sorry if y'all heard any weird like scraping noises. I had to clean my piercing.
No problem. And just so we
Yeah, I
can
got
get
my-
through it, CJ, I'm going to mute you just so we can get through the lesson. And then whenever you have to say something, you can unmute yourself whenever you have to answer a question. Yeah, and Tracy was saying it's fastest to use the biggest factor. If you're not sure, you can start with the smaller one, but then you're not done yet. And then you run the risk of saying, you know, I'm done, and then, oh wait, you're not. So that's why I have on here, list the factors of both numbers, because then you can pick the biggest one. So what can I multiply to get 15? What multiplies to be 15? 1 and 15, right? What else? 3 times what? 3 times 5. Yep. Is that it? I think that's it. Yeah, I think that's it. All right, what about 30? 1 and 30. What else? 15 times 2. 10 and what number? And 3. And what else?
5 and 6.
5 and 6. Very good. So now what is my greatest common factor? What is the biggest number that they both could be divided by that we have in common?
15.
15. Yeah, if you look at it, 15 is our greatest common factor. So if we divide both the top and the bottom by 15, then you'll get your, no problem. Then you'll get your completely simplified fraction right away. Okay, so the steps are list the factors, check for common factors, divide the numerator and the denominator by the greatest common factor. Oh no, I'm so sorry. Now you might choose just to divide by a factor. Just know that you'll have to continue simplifying it. Okay, any questions on this? If you have no questions, go ahead and type no questions, just so I know we're all alive out there. Or type nope, or no Q. I like that, that works. Fabulous, thank you. Please make sure that you're paying attention and writing this down just so you know what you're doing later. Because again, today we are reviewing all fractions, so it's kind of a lot, so make sure you write it down. All right, I need some friends to each pick one. So like, let's not have one person do all of them. So I want everybody to pick one. I don't care which one you do, but go ahead and write on there what you think the equivalent simplified fraction would be. Yeah, go for it. Harvey, you can do 3. Aaron, you can do 7. Lauren's gonna do 5. CJ's gonna do 6. Good. Thanks for claiming your number in chat, just so it. Cole's gonna do 8. Great, I think that's all of them, right? I think so. Oh, 7. I think someone claimed 7. But you can put your answer underneath, Ayla. You put your answer underneath. Go right ahead. So Ayla, you do it down here. Right there. That's Ayla's spot. Because you might not agree. You know, it's good to have lots of answers. And then guys, if you could put what you divided by up there too. So like underneath or wherever, put what you divided by to get that number. Perfect. Nice job. Oh, maybe I didn't have anybody doing number 4. Oh, I'm sorry. Let me get your sunglasses. You need some blue light ones. That's what I have. They're very nice. Oh, that's weird. I wonder if that's a connection issue. Can someone do number 4? We can do number 4 together. I'll do number 4. 4 is a good one. Okay, so I'm going to pretend I don't know. And I am going to write my factors down. Okay, so I know that to get 18, it's 1 and 18. 2 times what gives me 18?
9.
Harvey, yeah, 9. Harvey, if you want to try leaving and coming back in, you could try that. And that's okay. Sometimes you don't need to write the factors. I'm just doing it just because. So 2 and 9, and then what else? 3 times what number?
6.
6. I think that's it. 4, 5, yeah. Okay, 27, 1 and 27. I don't think 2 times anything. 3 and what?
9.
3 and 9. Oh, and then I think we stop right there, right? What do you guys think? We could stop right there. Why am I saying we could stop right there?
Because they're the same.
Yeah, because they have the same. They have the 9s in common. So we'll just divide by 9. 18 divided by 9, I know is 2. 27 divided by 9 is 3. Cool, cool. All right, let's check this one. This person said divided by 10. Yup. Anytime they both end in zeros, you just gotta chop off the zeros. It's just like dividing by 10. So that's the same for number 7 here. Cool, we get agreement. Yay. So we just chop off the zeros or divide by 10 and you get 3/8. This person said they divided by 3, which I agree. So 3 divided by 3 is 1. Admit. Cancel. Declan's here. Hi, Declan. So 3 divided by 3 is 1. And then 24 divided by 3 is 8. Then over here, 8 divided by 4 is 2. 12 divided by 4 is 3. This person divided by 8. Oh, what's 48 divided by 8?
6.
6. Yeah, so that should be a 6. Is it easy to make that mistake? Oh my gosh, yes it is. So it's really helpful to be aware of or maybe make a note of what you're dividing by. Okay, who has questions on those? You guys did a great job with that. Anybody have questions? If you have no questions, write no Q or nope. Awesome. If you come up with questions, you can private message myself. You can private message Tracy. You can come to Tracy's session on Friday. Okay, just maybe try the assignment and be like, this isn't making sense, and then go on Friday. No big deal. NBD, right? Alrighty, friends. Now we're going to add and subtract fractions, and we like this because this is when they have the same denominator. What is the only thing we add and subtract with fractions?
Numerator.
We only add the numerator. That's right. Very good. All the time, you are only going to add the numerator. And when the denominators are same, it's easy. You're just going to combine them. Just combine those numerators. So let's have you guys give this one a try. And I hate writing fractions sideways. I don't know why I did that. 3/6 minus 5/6. Oh, I know. Multiplying fractions is my favorite. I love that one. But we'll talk about that one in a minute. Okay, guys. Can I have some friends tackle these for me? Cole's going to do number 3. Lauren's going to do number 2. I need a 1 and a 4. Nolan's going to do number 1. I will do number 4. I got this. I can do it, but I might need help here because it's an integer. We have 3 minus 5. Remember, with subtracting integers, oh, good job. Very good. We're going to, and I'll talk about that one in a second. I'll give you guys a chance to write it down there. Ooh, and looks like Cole's answer over here, he got 4, 6. Those are both even numbers. So what's he going to have to do? Oh, Harvey, I'm sorry. If you can't take it, you can always watch the video. I will post it today after the session. But you'll have to diagnose the problem so it's not a repeat issue. Yeah, good job. Oh, both of these are even. So we're going to have to reduce.
Number 3 would reduce to 2/3.
2/3. Perfect. Perfect. We would what did you divide by there?
By 2.
Perfect. Good job. And this one's 5/7. What did they divide by for number 2? 2. Thanks, Cole. Yep, and Lauren. Thank you. We divide by 2. And 5/7. Great job. We just combined those numerators. Now it's the same deal here. If we had a mixed number, you might have to do some borrowing. I will put a video on Moodle that tells you about the borrowing thing. We're not really covering that just because we're doing a quick overview. I can, if it comes up again later, I might cover it next week. I'm not sure. But there's going to be a video on there that kind of explains about how to do it. It's not bad. It's just an extra step. Oh, I know, Nolan. Yeah, I'm kind of cheating a little bit. I have a pen and a pad. So, yeah.
Are negative fractions possible?
You know, technically, if you think of like the whole fraction and taking a piece away, no, but we're adding integers now. So we're talking about the negative space that's left behind. So if we're talking about like fractions of a pizza, maybe we're talking about owing slices. So like in this problem, there's 6 slices of the pizza. There's 3 slices left. This person took 5, maybe they stole 2 extra slices from someone else. We're going to figure out how many slices they stole from someone else. So
Good,
think
now
of
I want
negatives,
pizza.
right? I know. Think of negatives like owing. So we have 3 slices, and then someone took 5 slices. But that doesn't make sense because there was 3 there, so they must have stolen something from someone else. So let's figure out what was not covered by our original pizza. What do you guys think? What would it be? -2, yeah. That would mean 2 slices were left over from a different pizza, and then they were stolen, so we owe them that pizza back. I don't know, it works. But remember, when you're subtracting with fractions, we keep, change, flip the sign, okay? So it's like we have 3 of something and then we owe 5. So we owe 2.
I remember a few years ago, it's got to be, what, 5th grade, we were doing this, and the teacher played this really weird song that they found on YouTube.
Ooh, that's a
Explaining
challenge.
this.
That's a challenge. Now I'm going to have to find it. I totally will. I
Do
got
it.
this. I will. Okay.
Also, thanks to you, I've went from craving Chick-fil-A to craving pizza, which is a lot more expensive than Chick-fil-A.
I don't know what to tell you,
I
my
mean-
friend. I always think about food, so I understand that.
Is Chick-fil-A expensive? I've never been there.
They're a little more expensive than fast food, but not bad. Not bad at all. I love Chick-fil-A.
I've heard that they have very good chicken.
They do, and I'm gonna mute you just so we can. I know we're making everybody
Yeah.
hungry now, and I muted you, CJ, just because we gotta keep on cruising. So many fractions. Okay, so I know, right? So now we gotta talk about. Oh, I'm sorry. That's not fun. My son has new dietary restrictions, and it's really hard. It's really hard to. Yeah. Does. Okay, let's not look on YouTube. Let's look here. Got this. Got this. Okay. It's like the Wizard of Oz. Ignore the man behind the curtain. Focus on the fractions. I don't know. But okay, so we have 2 different denominators now. 2 different. Oh, no. No, no, no. We're not going there. No, no. No, no. That was just a Wizard of Oz reference. Sorry if I said that weird. I'll keep my movie references in my brain.
They meant Chick-fil-A.
Oh, I forgot about that. Yeah. you know, we'll keep that issue separate. There's a lot of heavy
Honestly,
issues. Yeah,
honestly, is chicken.
yeah. You respect the food they can make, maybe not their ideals, and it's within your right to not go to a place like that because of their
Yeah, it's kind of like the band of Bath. Like, sure, the drummer killed a guy, but it's good music.
right. There's a lot of things like that in the world, and do a lot of people have problems with Chick-fil-A? Yes, they do. That's right. But yeah, no, and I apologize. Maybe we shouldn't talk about that if that made some people uncomfortable because there's a lot of feelings out there about it. So we'll just focus on our denominators because our denominators are different. Yeah, we'll focus on. Yeah, well, that's a thing. You're right. If you have time, maybe look up what that means on the web and do a little research, and I'm sure you'll find some stuff. So. All right, so we have different denominators. We want to get them to be the same, okay? So in order to do that, you have to think of what number they could both become. And you're gonna pick the lowest common multiple. So this is different than greatest common factor. It's lowest common multiple. So here our denominators are 6 and 9. So we would list the multiples of 6 and 9. And that's just counting by that number. So 6, 12, 18, 6 times 4 is 24, etc. And then counting by nines, what would the nines be? 9, you guys type it. What is it?
18.
18, yep. Oh, and we can stop there. We don't even need to go further. Why?
Because there's two 18s.
There's two 18s.
18
This,
is equal to 18.
yep, this is our lowest common multiple. So that tells us that both of those denominators could turn into 18. So that's what they're going to do. And in order to get 18, 6 times 3 is 18. And then whatever you do to the bottom, you have to do to the top. And then in order to get 18, 9 times 2. And whatever you do to the bottom, you do to the top. And then we add. So that's what we're going to practice really quickly before we get to do other stuff. Okay. So I will do number 8. Let's do that one. So number 8 has a 6 and an 8. Let's list those multiples just for grins. You're not going to need to do this every time, but I like to write stuff with my cool pad, so why not? So, okay, let's count by 6s again. We have 6, 12, 18, 6 times 4 is 24, da, 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 da. Okay, then 8 times 2, what's that?
16.
16, 8 times 3?
24.
24, oop, bingo, look at that. We have our multiple. So both of those denominators have to turn into 24. Okay? And then how do you get from 6 to 24? 6 times what is 24?
4.
4. So you got to do the same to the top. 5 times 4, what does that give me?
20.
20. Thanks, Cole. Look at that. 8 times what gives you 24?
3.
3. So you do the same to the top. 3 times 3?
9.
9. Cole's on fire. Nice. Okay, so then our denominators match. Now we're going to add 20 plus 9 is 29 over 24. Ooh, look at this. We have an improper fraction. So we got to turn it into what?
Mixed number.
Yep. Does anybody remember how to do that? Can anybody say the thought process of how you do that?
I can.
Do it.
All right. What's the mixed number in question?
29 over 24. Sorry. Go back in. It's an improper fraction. We want to get it to a mixed number.
29 over 24. Okay. So you're going to take the 24 out of the 29. So you have 1.
1.
And
It
then
goes in once.
Yep. And then what's left? Well, you got 5. So it's 1 and 5/24, or actually, I can't reduce that. I was going to say almost 1 and 1/5, but you can't do that.
Right. If it was 5/25, you would be right. Great job explaining
Yeah.
that. That's exactly what you have to do. Very, very good. So he is exactly right. You figure out how close, how many times the denominator can go into the numerator, write it out front, and then whatever's left goes in the top. Good. And just for grins, because it does show up in your homework, let's talk about this. Thanks, Isaac, for turning your camera on. Hi, Isaac. So good to see you. Okay, so we have a mixed number here. Let's take a random mixed number. 6 sevenths. Does anybody remember the little rhyme that helps you turn it back into an improper fraction? Nobody? Bueller. Okay, I'll sing it for you in my pretty voice. You take the bottom times the whole, add the top. Right? Have anybody heard that?
No.
Am I alone here? I'm
No,
alone here.
you're-
That's
you're
okay.
alone.
That's
Did
okay.
it last year.
You
No.
did! Aaron knows what I'm talking about. Yeah. Okay. So bottom times the whole. So 2 times 7. What is that? What's 2 times 7?
14.
14. Bottom times the whole, add the top. So now 14 plus 6.
20.
20. Very good. So it's 20, and then you use the same denominator.
Yes.
Done. Boom. Look at that.
Math. We did
Okay. Math. Okay, let's pick one more of these non-common denominators to do. Unless I have
How about
friends.
10?
Should we do 10?
Yes.
Yeah, let's do 10. Let's do 10. Okay, so 10, what
10
would
is
be the
easy.
common multiple?
4.
4, right? Common factor multiple. Yeah, I always get those words confused. Multiple would be 4, right? Both of those can turn into 4. And sometimes you have that. Sometimes one of them is already there. So we don't even have to worry about this friend. But we have to turn the other one into that. You might know it right away. What does 1/2 turn into with 4 as a denominator?
2.
2/4, yeah. And then you're just gonna subtract those numerators. What do you get?
1/4.
1/4. Bingo bango. We are done. What would the common multiple be for number 7?
24.
24. Yeah, how did you get that one?
4 times 6.
Yes. Sometimes all you can
Oh,
do
right.
is just multiply those denominators together. And that tells you what it is. And if it's not too high, I say go for it. Pick that one. But if we did it down here, we would have gotten 8. And we would have done a little bit more work than we need to. So sometimes,
We would have to reduce at the end.
yeah, you would have to reduce again. So sometimes go for it. Sometimes maybe try and think it through a little bit. So 4 times what gives me 24?
6.
6. Do the same to the top. 6 times 2 is 12. 6 times what is 24?
4.
4. Same to the top. 4 times 3 is 12. So we actually get 24 over 24, which is what?
1.
1. How do we feel about this, my friends? Pretty good?
Neutral.
Fractions are the best. Go fractions. Go fractions. All right, now we're going to get to Lauren's favorite, multiplying. All you got to
Yay.
do when you multiply is you multiply straight across the top and straight across the bottom. That's it.
Right, that's really easy. What's the catch?
No catch. I promise. You might have to reduce, but there's no catch. Sometimes it's easier if you look at the problem. Like look at this one. 2/5 times 3/4.
Cross multiply.
Oh, who said that? I think that was Cole. Yeah. That's right. We're not going to cross multiply, but we can cross cancel here to make our problem lower. So if you look diagonally, this 2 and this 4 could be divided by something. What could they both be divided by?
2.
2. So 2 divided by 2 is 2. 1. Sorry, Jen. 2 divided by 2 is not 2. It's 1. And then 4 divided by 2 is 2. And then you multiply.
Big math skills.
Big math skills, right? Yeah.
Yeah,
So-
2 divided by 2 is 2.
Right? That's where I'm at today. Okay, 1. Now we're going to go.
1 is 7.
No. Okay, now we're going to go straight across the top and straight across the bottom. 1 times 3, 3. 5 times 2 is 10. So see, we got the same answer. We just didn't have to reduce.
I like that.
So it's kind of cool. And you can do that anytime you have numbers diagonally that can be like reduced or divided by a factor. It's pretty nifty. All right, let's do this. So let's use that cool little trick for number 2 here. What could be reduced diagonally? What could be simplified a little more?
The 8 and the 2.
8 and the 2. What could they both be divided by?
2.
2. So let's do that. 8 divided by 2.
It's 4.
4. 2 divided by 2.
2.
1.
1. Not 2. 1. And
Or
now,
you could arguably do the 3 and the 1 as well.
right.
Wouldn't make
No.
Not the 3 and the 1. You could, but it wouldn't change the numbers.
Yeah. it
Yeah.
wouldn't change.
Tell her or tell me. Tell me or what? What did I miss? I see in chat. Someone gonna tell her or did I miss something? I'm sorry if I did. Okay, cool. Just check it. I don't either. If I missed something, let me know because it does happen, right? So we're going to multiply straight across the top. 4 times 1 is 4. And then straight across the bottom. 3 times 1 is 3. Oh, it's a improper fraction.
It's 1 and 1/3.
1 and 1/3. 3 goes into 4 one time, and there would be 1 left over until you get to 4.
Say that again. Just think about that while you're saying it.
Yes.
You
Yes.
said 3 goes into 4.
3 goes into 4 one time with 1 left over. That's our remainder. I know. It sounds weird. It does. It
That
does.
sounds backwards.
I know. It does. I apologize. Okay, so we're going to multiply straight across the top here and straight across the bottom. So what would I get if I just multiply across the top and the bottom?
4,
4,
6.
6.
4, 6. And
Yeah,
what would
4,
that,
6. I didn't see that.
that's okay. What would that reduce to?
2/3.
2/3. Yeah, you would divide both of them by 2 and you get 2/3.
Wait, no, we reduced the 2 to a 1, so it's actually 4 which is 1. Okay. Oh, it's the other one. Oh.
Otherwise, yeah, I know, I'm throwing a lot of fractions at you guys. I get it.
Ah,
I get it.
ah,
And now guess what I get to do? I got to talk about division super quick. Super quick. Division is just like multiplication, except we got to do our same thing. We're going to KCF it. Same thing here. We're going to KCF. We're going to keep the first fraction the same. We're going to change it to a multiplication problem. And instead of flipping the sign of the second fraction, we're going to flip the numerator and denominator. So I would write that part down. I would write this down right here. KCF, keep, change, flip. And then we just treat it just like a regular multiplication problem. Questions on that? So if I had a different problem here, if I had like 2/3 divided by 4/5, I would keep the 2/3 the same. I would change it to multiplication. And what would my second fraction say? Hey, that works too. I love lots of methods. I love that. What would my second fraction become if I keep, change, flip? What would that second fraction become? I pulled another problem here. Guys, look at the screen here. Up here, last thing, I promise. What would that second fraction turn into?
5/4.
5/4. Thank you so much. We would just flip the 4 and the 5. Okay? All right, friends and neighbors, that's all I have for you. I will post this video. Let me know, or Tracy know, and don't forget about Friday, please. She's gonna send you an invite, and then I will post the link on the page. I'll figure out how to do that. But you have a great day. Thank you.